Welcome back student to this thin layer chromatography part 3. In part 2, we have studied the steps of thin layer chromatography, operation of thin layer chromatography, in which we have studied choice of adsorbent, various adsorbent used in thin layer chromatography, their classification and various examples we have studied. Then preparation of plate, what are the various techniques to coat the plate for the chromatographic purpose. Then preparation and application of sample on the plate. And the last part we were discussing, that is choice of the solvent, that is mobile phase. So selection of mobile phase, the organic solvent mixture of low polarity is generally used for this purpose. High polarity solvents are avoided to minimize absorption of any component of the solvent mixture. Use of water as a solvent is avoided as it may lose adhesion of layer on the glass plate. Solvent with an increasing degree of polarity are used in liquid solid or adsorption chromatography. So solvent listed in allotropic series are selected for the purpose. In the previous video, we have seen the various solvent used for the chromatographic purpose. Now the next part is a preparation and of the developing chamber. It can be specially designed chamber. A jar with lid or beaker with a watch glass can be used for this purpose. You have to pour the solvent so that the baseline should not dip into the mobile phase. So you have to maintain less than 0.5 or 1 centimeter depending upon how much distance you are taken to mark the baseline. Then add the saturation of TLC chamber with the solvent vapors. You can line part of inside of this beaker with filter paper so that you will get the maximum saturations. Cover the beaker with watch glass, swirl it gently, allow to stand while you prepare the TLC plate. So this will taking a saturation period of 30 minutes to 2 hours. So equilibrate the atmosphere of empty space in chamber with the mobile phase. This is also known as saturation of TLC chamber. Aging effect occur when the solvent front in the middle of TLC plate moves faster than that of the edge of the plate. So this is due to the non-saturation of your mobile chamber atmosphere. So you need that the atmosphere should be saturated well, otherwise it will cause the age effect. Now in modern chromatography, we are using these twin trough chambers. So it is divided in two sections by a reed at the base. For standard linear development, solvent consumption is 20 ml for 20 to 20 by 20 centimeter plate and 4 ml for 10 by 10 centimeter plate. It is considerably low in twin trough chambers than in normal chambers. This reduces material and disposable cost also. The another advantage of this twin trough that in one trough we can add the mobile phase, and in another trough we can keep the spotted plate so that the plate will get saturated with the environment of this mobile phase. After saturation of the plate, this chamber can be tilted so that the mobile phase moves to the other side and development will start. Development of the TLC plates. Different development techniques are used for efficient separation. They are vertical development, like your ascending paper chromatography. This is the ascending chromatographic technique where against the gravitational force, the liquid moves onto the plate. Horizontal development, like your circular paper chromatography, the plates are kept horizontally and the edges of the plates are deep into the mobile phase, which is kept on the side wall, and spots are given exactly in the center of plate and they are allowed to travel on the plate. The third one is two-dimensional development. Many times the complex mixtures cannot be separated by single development. So we need to develop it twice. So once it is developed, it is again rotated to the 90-degree angle, and again a second development is done so that the complex mixture can be separated easily. Then in multiple development, the various spots are given and their development at the different rates. Now in modern chromatography, that is HPTLC, we are using the AMD. AMD, that is automated multiple development system, like isocratic system which are used in HPLC. Same type of the multiple development systems are available in the thin layer HPTLC. After completion or development of the chromatographic plate, drying of chromatogram is essential. After the solvent has moved to a certain distance for certain time, the chromatogram is taken out from the tank. Position of the solvent front is marked. They are dried by cold or hot air depending upon volatility of the solvent. The simple hair dryer is convenient device to dry the chromatogram. After that, the visualization of spot. If there are any colored spots, circle them lightly with the pencil. Most samples are not colored and needs to be visualized with suitable visualizing method. Two types of visualization methods are available. One is called as a physical method of visualization, such as using the ultraviolet light, or chemical method of visualization, where we can use the iodine vapor to stain the spots or color reagent to stain the spot. While you are using the physical method, that is using the UV lamp or the plate, circle the spot when it is in the plate. Make sure you are wearing goggles and do not look directly into the lamp. Protect your skin by wearing the gloves when you are operating in UV light. The various visualizing agents are listed here. The common visualizing agent is your iodine vapors. A chamber of iodine vapors are used. So they are useful for the general organic compounds with the unsaturated compounds. They are reversible one. We can reuse the sample after visualization also. Then phosphomolybdic acid, it is also a general organic agent for the visualization purpose. Then fluorescein bromide, it is also a general organic agent. The another one is your sulfuric acid, corrosive. Sprays of sulfuric acids are used. That is also the general organic agent. Organic substance can be visualized by this. Ninhydrin, as we know that amino acids can be visualized by spraying with the ninhydrin. The ketone and aldehyde can be visualized by using 2,4-dinitrophenylhydrazine solutions. Metal ions can be visualized by H2S water or diphenyl carbazide or rubanic acid sprays. Then steroid and essential oil can be visualized by using antimony trichloride. So various visualization techniques are available. After visualization of the spot, we need to interpret the data. For that, we need to calculate the RF value. So RF value for each spot should be calculated. RF stands for ratio of front and it is characteristic for any given compound. Hence, known RF value can be compared to those of unknown. Substance to add in their identification. For substances that are very soluble in the liquid, RF will be closer to 1. Rather, insoluble in the liquid, that is mobile phase, RF will be closer to 0. So RF is a distance from the start line, that is from the baseline of a solute to the distance of the solvent front. So we are taking the RF value and we are comparing this RF value with the standard and reference. We are simultaneously spotting standards and reference on the plate. So why to spot standard and reference simultaneously? So that are the various factors affecting the RF value. First is nature of absorbent. Different absorbent will give different RF value for same solvent. Reproducibility is not possible for given absorbent of constant particle size and binders. Plate should be stored over the silica gel in a desiccator before use, and the sample should be applied quickly so that the water vapors in atmosphere is not absorbed by the plate. The second factor is a mobile phase. The purity of solvent and quantity of solvent mixture should be strictly controlled. It should be made freshly for each run. If one of the solvent is very volatile, hygroscopic, for example acetone, care should be taken. The third factor is a temperature. Although precise control of temperature is not necessary, the tank should be kept away from dark sources of heat, direct sunlight, etc. As the temperature is increased, volatile solvent evaporates more quickly and solvent run faster and RF value generally decreases slightly. The next factor is the thickness of layer. Standard plate approximately of 0.25 mm is preferable thickness of layer. Below 0.20, the RF value varies considerably. The next factor is developing tank. It is important that saturated conditions are attained for running the TLC plate. This is best accomplished by using small tanks with filter paper lines and sufficient solvent, and by leaving the tank to equilibrate for at least 30 minutes before running the plate. The sixth factor is your mass of the sample. Increasing the mass of sample on plate will often increase the RF value of drug, especially if it is normally tails in the system. However, the higher concentrated solutions will cause the tailing effect, and it will be difficult for measurement of the RF value if tailing is there. Then the last factor is a chromatographic technique. Depending upon the development technique used, that is ascending, descending, horizontal, etc., the RF value changes for same solvent system. Therefore, it is essential to spot the sample and the reference together on the plate so that we can identify the unknown. Application of TLC. It is used for separation of all classes of natural product and is established as an analytical tool in modern pharmacopoeias. It is used for determination of acids, alcohols, glycols, alkalides, amines. It is also used for separation of micromolecules like amino acid, proteins, and peptides and antibiotics. It is used for checking the purity of samples, that is as a purification process. It is also used for examination of reaction, how much the reaction is proceeding, that can be again identified or checked by using the thin layer chromatography. For identifying organic compound, extensively used as an identification test and test for purity. As check on the process, checking of distillation fractions, and for checking the progress of molecular distillation, TLC is a choice for it. The other use of TLC includes determining the number of components in a mixture, determining the identity of two substances, monitor the progress of reaction, to determine the effectiveness of the purification process, to determine the appropriate condition for column chromatography. The mobile phase selection is first done by using this thin layer chromatography. Then to monitor the column chromatography, the various fractions collected in column chromatography are spotted on the TLC plate, and number of spot will decide how many samples have been separated. So here we have completed the thin layer chromatography. Thank you and happy learning, friend. See you in the next chapter.